Welcome to this tutorial on seasonal forecasting. We're going to go through an example of working with seasonal data in Excel. So working with seasonal data is 6 main steps to it. You start with calculating your centered moving average, then you go on to your specific seasonals, use that to calculate your seasonal index, use the seasonal index to deseasonalize your values, and then from there on you can go to forecasting. So we're going to start with the centered moving average. Problem with centered moving average over even number of seasons per period is that when we're trying to calculate the centered moving average for time 3, it doesn't really fit. So we have to do an average over time 2.5, which is these 4 over here, sort of right in the middle there, and time 3.5, which is these 4 over there, right in the middle of there. So if we average those 4 with those 5, we get the centered moving average at time 3. And if you do the arithmetic, that pretty much works out to this formula over here, T1 divided by 8 plus the sum of T's 2 to 4 divided by 4 plus T5 divided by 8 again. Then we have our centered moving average for T3 that we can drag down all the way down to T18 quarter 2 1985. Now we're going to go into step 2, which is very simply just calculating our specific seasonals. We do that by taking our actual Y value, actual value at that time, divided by our centered moving average. And we're going to copy that down for all time periods for which we have a centered moving average. Alright, let's go into step 3, which is calculating our seasonal index. In order to do that, we're going to find every specific seasonal from each of the quarters, sort of tabulate them and create a nice simple average. So in order to do that, we could do it manually, but you should never have to do anything manually in Excel. So I'm going to use a VLOOKUP function. Our lookup value is going to be just that whatever quarter it is that we're looking at. Let's fix that row, because that row is never going to change, so we can copy it through it without a hassle. This is going to be our table. Let's fix that as well. Column index is going to be 1, 2, 3, 4, 5. And then we're going to just say false, so we're finding an exact match. And great, there we can see that finds us the first instance of the quarter 1 specific seasonal 1.867. So that function is going to work great if we just want to copy it across here, but it's not going to work too well if we want to copy it down, because it's always going to be finding the first one. So let's just make a quick change to this formula so that it moves this range down depending on whether we're looking for the first, second, third or fourth of those specific seasonals. So we're going to use the offset function to do that. We want to offset that range by how many rows. We want to say number of rows is going to be whatever's in this cell over here, minus 1, times by 4. We don't want it to move any columns. The other parameters are optional, and there we go. And then the final change that we need to make to be able to copy it right across is we just need to fix it in this column, fix the reference value in this column. There we go. And now as you can see, it'll copy across quite well over here, quite well over there, and it's finding our last values. Then finally, to get the specific indexes, we just calculate a simple average of what's above. And now the final step is just to take each of these seasonal indexes and reference them back, the quarter 1 going to all the quarter 1s, 2s to 2s, so forth. So we could do that manually, but let's save some time by using an HLOOKUP function, which is going to look horizontally, find the season, match the quarters, go down, get the seasonal index, put it in for us. So our lookup value is going to be our quarter. Our table array is going to be that. I'm going to fix that. F4 is a nice shortcut for that. Our row index number is going to be 1, 2, 3, 4, 5, 6. And there we go. And it's finding all of them for us and putting them in. Now that we've got our seasonal index, we're going to go into the next step, step 4, which is deseasonalizing our values. So we're going to take each of our values, divide them by their appropriate seasonal index. That gets us our deseasonalized value for each time period. And in this chart over here, we can quickly see what that's doing. So here were our seasonal values, and that deseasoning process, it sort of smooths it out. It takes out a lot of those peaks and troughs and gives us data that's easier to forecast, either using a node trend or a trend technique. Right, let's jump into step 5, where we actually use these values to conduct our forecast. So we ran a regression analysis on time 1 through 20, and these deseasonalized values, and we're going to use the output of that regression analysis, namely the coefficient and the intercept, to conduct a deseasonalized forecast. So the first thing we're going to do is we're just going to extend our time, make this 1936, can extend these, and we're also going to need to extend our specific seasonal. So if we just copy this formula down here, it'll still work. Then what we're going to do is we're going to use our intercept and coefficient over here to calculate our deseasonalized forecast. That's going to be whatever our time t is, times by our coefficient. We want to fix that, plus our intercept, and we want to fix that as well. I'm just going to copy that all the way down. So that's our deseasonalized forecast. Now to seasonalize that forecast, we're going to take the deseasonalized forecast times by the seasonal index, gives us our reseasonalized forecast. And there we go. We can see what's going on visually when we look at this chart over here. Here's our deseasonalized values. There's the regression line that we ran on those deseasonalized values. And you can see on this chart over here what happens when you reseasonalize our trend. You can see it fits in quite well with the actual seasonalized values. So the purple line is our reseasonalized forecast. You can see it quite well captures both the general trend and the seasonal variations. And here's all that data together. You can see there's in the red the actual values, actual seasonalized values, in the blue the deseasonalized versions of those, in the green the forecast based on those deseasonalized versions, and in the purple the reseasonalized forecast.